Hello everyone, I am Shrutika. Today we are going to learn about 4:1 mux coding using Verilog. Let's move towards the content for the presentation. So this is the all over content for the presentation, namely Introduction to Multiplexer, 4:1 Multiplexer, Verilog data flow modeling in Verilog, Verilog code for 4:1 mux, and some real life application for multiplexers. First of all, let's move towards the introduction to multiplexer. The definition and function for the multiplexer is as follows. A multiplexer, which is also known as mux, is a conditional circuit that selects one of many input signals and forward it to the single output line. The selection of the input is controlled by additional input known as select lines, which is also called as conditional statements. Now, knowing the multiplexer term in more proper manner, let's jotting down this multiplexer with real life application, which is a multiplexer can be compared to a multi-input switch where the select lines determine which input is sent to the output. Now, moving towards the 4:1 multiplexer. A 4:1 multiplexer has 4 input lines, 2 select lines, and 1 output. The select line is namely S1 and S0 determine which of the 4 input from I0, I1, I2 and I3 is passed to the output. Now the general formula for any multiplexer is given by 2 to the power n is equals to number of inputs, where the n indicates the number of select lines. So this is the circuit diagram for the 4:1 multiplexer, and here is the truth table for the multiplexer. When the two inputs are low, one input is low and one input is high, both the input are high, what is the output condition for the multiplexer is given into the truth table of 4:1 multiplexer. Now moving towards the Verilog, the most important part for the presentation. Verilog, a key tool in digital design. Now what is Verilog? A Verilog is a hardware descriptive language used to model electronic systems. It allows designer to describe the behavior of digital circuits systems for simulation and synthesis. Then the most important thing, why the Verilog is important, why not other language, why we are not using other languages like VHDL and industrial languages. So the answer is Verilog is essential because it enables a digital designer to prototype, verify, implement and design quickly, helping streamline the process of creating complex integrated circuit. In short, it reduces the code line, complexity of circuit and the overall programming it makes easier. These are some key points that the Verilog plays important role in chip designing system. Now moving towards the data flow modeling in Verilog. So here is the explanation of data flow method. Data flow modeling describes the flow of data through a circuit using continuous assignment. In Verilog, it is more abstract than structural modeling, focusing on the behavior of the circuit based on the input. Now the advantages of data flow is continuous data flow modeling results in fewer lines of code, as we are discussing in previous line, that it reduces the code line of the program. Then ease of understanding, it is closer to high level design description, making it easy to understand the circuit behavior. That means it gives more understanding about the code and the circuit by itself of reading the code. Then efficient simulation, circuit can be simulated faster in data flow compared to gate level modeling. That's the most important point here. Then moving towards the most important part, which is Verilog code for 4:1 mux. So here is the code explanation and result for the 4:1 mux. Now here in module declaration, we are giving the module name as mux 0. In the module declaration part, we are declaring the input, output and select lines. Then in assign statements, we are assigning the values or we are assigning the code for the 4:1 mux or any other circuit. Then we are using here a ternary operator. It is used for selecting a condition to appropriate given to the output or select lines. Then end module. Here the module is in. As we can see, it is reduces the all over complexity of the code. It reduces the number of code line compared to VHDL. Here we are not, it is not necessary to declare the libraries, declare the separate entity, or declare any separate component, we can simply and shortly write the code in using Verilog. Now this is the result for RTL schematic for the code. Here we are giving, as we can see, four inputs, which is A0, A1, A2 and A3, S1 and S0 as select lines, and Y as output. Now this is the test bench waveform for the Verilog code which we are writing for the 4:1 max, as we are giving the inputs and we are getting the required outputs. Now let's moving towards the real life application of multiplexer. We are learning or knowing more about the multiplexer like home automation system, audio and video system, automotive electronics. Here we are seeing the multiple application of multiplexer which are using in daily life purpose. In this picture we are seeing that typical application of MUX as a single multiplexer which has multiple inputs as MP3 player docking station, laptop sound card, then digital satellite, then digital cable TV, which we can connecting with the second example as audio and video systems. Here we are giving that multiple input which are multiple sources, then selector working as a multiplexer, and then single destination which is the output as surrounded sound system. Here we can see some description for the real life application that MUX allows for the selection between the different audio and video input in multimedia system like home theaters, conferencing equipments, then automotive electronics. In modern cars, multiplexer help manage multiple signal from the sensor and control units, allowing efficient communication between the system like infotainment, engine control and safety features. And one more basic application which we are familiar with, like we are suppose there are two rooms and there is a one switching board, there are multiple inputs and the output result into the glowing of bulb of two rooms. Then we are giving multiple inputs and we are selecting the buttons one by one which plays as select lines and conditional statements, and we are pushing the button as the inputs and the result as glowing of the bulb. So this is all about the whole coding of 4:1 MUX using Verilog and some real life application of 4:1 multiplexer. Thanks for watching this video.